The main issue in the design of a multi-biometric system is to determine the type of information that should be combined by the fusion module. In a typical biometric system, the amount of information available to the system get compressed as one proceeds from the sensor module to the decision module. As you can see in this figure, the amount of information that we have in the sensor module is 142 kilobyte. This is an image of a fingerprint. Then we give it to the feature extractor module, and the minutia feature will be extracted. The size of this feature reduced to 112 bytes, and then we give this minutia features to the matching module, and the matching module give us a match score, a number which can be stored in 1 byte, and finally the decision module receives the match score, and according to this match score it will decide to reject or accept this, and this identity decision can be represented by 1 bit. So as you can see, when we move in this direction, the amount of information reduced from 142 kilobyte to only 1 bit. Of course, the raw biometric data is the richest in information content, and the subsequent processing reduces the amount of information that is available to the system. In a multi-biometric system, fusion can be accomplished by utilizing the information available in any of these 4 biometric modules. So we can combine the information that we have in the sensor module, feature extractor, decision module, or matcher. Generally, biometric fusion can be classified into 2 categories: fusion prior to matching and fusion after matching. In this figure, you can see the various levels of fusion possible in a multi-biometric system. We can have fusion in sensor level or feature level. These are both of them before the matching module, and after the matching module we can perform a score level fusion, rank level fusion, or decision level fusion. Integration at the feature level is expected to provide better recognition results than a score or decision level fusion, because the feature set contains richer information about the input biometric pattern than the match score or the decision label. But in practice, this is not always true. First of all, the presence of noise can affect the performance of the system. Also, maybe we need a new matching algorithm to compare two fused feature sets. Therefore, fusion at sensor or feature levels introduce additional processing complexities. In sensor level fusion, we combine the evidence presented by multiple sources of raw data before they are subjected to feature extraction. And in feature level fusion, we combine the evidence presented by 2 different biometric feature sets of the same individual. In this figure, you can see the information flow in a multi-biometric system that employs sensor level fusion. We have m different enrollment samples. We give them to the sensor level fusion module, and all of these samples are given to the function f, the sensor level fusion, and it gives us a fused version of these samples. Then we give it to the feature extractor and receive one feature vector and we save it in an enrollment database. Then in the authentication procedure, we have several samples here. Again, we give them to the same sensor level fusion module, and then after they combine to each other by some way, we give this combined samples to the feature extractor, and finally this authentication feature set will be compared with the feature vectors that are saved in the enrollment database, and then matching score will be given to the decision module, and decision module decide about to identify or reject this subject. In this picture you can see the information flow in a multi-biometric system that employs feature level fusion. So for each sample in the enrollment, we use different feature extractor module. Assume that we have m different feature extractors. So from each sample, we extract several feature vectors. Then these feature vectors will be given to the feature level fusion module. For example, we concatenate them one by one to each other, and the final fused feature vector will be stored in the dataset, and we can do the same thing in the authentication procedure. After we extract several feature vector for each sample, we combine these feature vectors to each other and compare these fused feature vector enrolled feature vectors, and the matching module compute a score, and it will given to the decision module, and decision module according to this score decide to reject or accept this one.